All right, good morning. How's everybody doing? Yeah, something happened. Pretty good. Yeah, something happened with the Linux server this morning. So it froze on everybody. I was not able to connect to it, and I went to the service provider, and their status said the system was unavailable. So I went ahead and issued a reboot request. And then the provider's website went down, and then after a few minutes it came back. So I think it was a problem with the provider themselves. I think they had a network issue. But anyway, the punchline was the server got rebooted, and it seems to be up and working fine now. But this happens once in a while. It's a good cautionary tale, though, right? So you absolutely want to make sure that you're doing backups and that you have your own backups. In case, something happened and either, the hard drive got corrupted and all the data disappeared for good, or, the more likely scenario, something goes wrong and the files are unavailable. Oh yeah, I need to put stuff back in temp. Thank you for letting me know. And also, ideally you have access to Linux outside of the server, either on a laptop or through Dropbox. And then if something happens and say the server is down for a weekend, you're not, dead in the water. You can pull your files back from Git, put them on your VirtualBox implementation of Linux and keep chugging away, and you don't need the server to submit your code. So make sure that you've got contingency plans like that in place. And let me put our temp files back up on the server. Let's see. I wonder which file I had up there. Okay, I think that's the one. What did I call the temporary file on? Was it just knapsack? Okay, data files, knapsack data. What about the executable? Knapsack, okay, cool. Lowercase k, I think. Alright, that should be back in place. You should be able to pick those up. And yeah, it should be good to go. I'm going to go ahead and mute everybody's microphones. Alright, cool. So yeah, hopefully that was just a hiccup. Any questions on anything? Besides what happened to the Linux server. So I posted an announcement with the Zoom info for Monday's SLP presentations. And don't come to the regular classroom Monday at 10. Go to that Zoom room instead and wait for me to put you into a breakout room. And then you can go ahead and do your presentation. So I posted a bunch of details there. But any questions, let me know, preferably right now. You're right about something going wrong towards the end. It looked like it all works now. Oh, good, cool. Excellent. Yeah, that's probably the truest nugget of wisdom that I've learned in like close to half a century. So, and I have no idea why. All right. Any questions about tries or about anything on the quizzes? So the quizzes are due at midnight tonight. I'm not going to be online after my my discrete structures class. So if you have questions about the quizzes, this would be a great time to ask them. And I think we went through enough about tries to answer the questions on quiz 5. But any of the other quizzes also, any questions? No? Everyone good to go? Left, right, left, left, right, 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 left rotations. Oh, is that on a quiz? Which quiz number is that? Quiz 7. Oh, I didn't even know there was a quiz 7. We may have to ditch that quiz. Let's see, left node, right tree traversal, deleting the root in the node, the height of an empty tree, recursively inserting into a tree. All right, so so I'm planning to go through this next week. But yeah, so left, right, left, left, right, 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 left rotations of a tree are used after inserts to maintain balance. So there's the answer to that one. And we'll explain it next week. Well, we'll come back and yeah, I don't even know if I put reasonable guesses to replace the root with a leaf node. Search for values not found at the root. Calculate the balance. Yeah, so most of those answers are totally bogus. But when we come back to this next week and we start talking about balancing trees, right? There's the notion of the balance factor of a tree, and you know, trees begin life perfectly balanced, like most of us, because they're null, and a null tree is balanced. But as you insert things into a tree or delete things, it can become lopsided. And the trick to keeping a tree balanced is to adjust it at any time that you do an insert or a deletion. And so we'll go through how we analyze a tree following an insert or a delete to see if it's unbalanced, and if it is, how to restore balance. And it's usually a matter of doing one relatively simple operation where we basically kind of rotate things around a node in order to, you know, more equally distribute things on the left and the right. And so we'll go through those in some detail, but those rotations are called left, right, left, left, right, left, and right, right. So that's what those abbreviations are. All right, cool. So pass that on to other people if they ask you about question 4. You can tell them, since we discussed it openly in class. I'll actually make it a tagged entry in the video so people won't have to look too hard. All right, cool. Other questions? Or questions about PA5? Do you want to go over this business of returning the inventory from MaxVal? Okay. Because that's usually some confusion around that. All right, so if we're not returning the inventory, right, how do we find the maximum value recursively? So typically we have an integer function which takes a capacity, returns an int, and we do something like this: integer best equals 0 for each item I if weight of I is less than or equal to capacity. Call your maxval function. To find the maximum value you can get from a bag that holds that much less stuff. Right? So take off the weight of your item from your capacity, call maxval, see what the max value is you can get from that remaining space in your bag, and then say if that maximum value plus the value of item I is better than the best answer you've got so far, save it. All right, when you come out of there, just return best. All right, this is not doing dynamic programming yet. This is just looking at the straight maxval function. Give me a capacity, I'll give you back a maximum value. That's the best maximum value we can get out of that capacity. If we want to do dynamic programming, right, we do some lookup here to see if we've calculated the answer for this capacity, and if so, we return it. If not, we do our calculation, and then at the very end, we save our answer in our lookup table for that capacity. So we're not going to worry about the dynamic programming part. We're just looking at the maxval function. So this is purely just to get the integer value. What is the maximum value? But it doesn't get you the inventory, right? So if you also want to record the number of each item that you should have to get that maximum value, all we got to do is change this a little bit. Okay, so we're going to make a structure, and I keep calling it answer, so I'll stick with that. And answer has two pieces to it. Let me call it maxval. Right, it's got a field called maxval, which is the maximum value we can get back. But it's also got an array of how many of each item we should have. So a total of 128 items at most, so we have an array of item counts. We have 128 of these. All right, so instead of maxval being an int, it's going to return a struct answer. We're going to do exactly the same thing, though. We're going to iterate across all the items that we can choose from, and for each one, assuming it fits in our bag, we'll find the best possible value we can get after we've put that item in our bag. We'll add that to the value of this item, and if that's a better solution, we'll record it as our current best solution, and when we're done, we'll return that best solution. So the mechanics are a little different, but the idea is the same. So our best solution is no longer just an integer, it's a struct answer. All right, we can't just set it equal to 0 because it's not an int, so we need to initialize. And write yourself a loop to do that. So set, best dot max val equal to 0, and then make a loop that says best dot item count bracket each index is equal to 0. So do your initialization. And then, again, for each item I, if the weight of I is less than the capacity, or equal to. So temp is not going to be an integer, it's going to be a struct answer. So call max val capacity minus the weight of item I. And save that partial answer under temp. And then, we want to know if the maximum value we got plus the price is better than our best price. So if temp dot max val plus price is bigger than our best answer so far is a structure, but we're interested in the max value piece, so better than best max val. If that's the case, we want to save this solution as our current best solution. So I'm not just going to do best equals temp plus price I, because this is an int, this is a struct, this is a struct. So let's do this. Set best equal to temp. And that copies over this list of items. And then best dot max val equals, well, what's our value? It's temp max val plus the price. This is item I. And then we need to adjust the inventory. So this answer, temp, contains the item count to get us this maximum value. But this best solution that we've got is what we got by solving this max val problem, but also starting off with one of item I in our bag. So we need to take the item count that we got back from max val, bump up the item count for item I. So that's just best dot item count bracket I. And that basically takes into account the fact that you're starting with one of item I in your bag. And then at the end, just return best. Best is a struct answer, max val is set up to return a struct answer. So there's some legwork to put into there, because this is still pseudocode-ish, but that's the idea, right? My suggestion, if you haven't gotten things to work yet, is code up your maximum value function just for integers. Just find the maximum value without worrying about the item count. And if you want, at that point, go ahead and write your cache code. Your cache code is really, really short, right? In the very beginning, see if save bracket cap is 0. If it's not, return it. If it is, do all of this, and at the end, set save bracket cap equal to best, and then return best. Get that working, clean that up, submit it. You're good for 85 points out of 100 at that point, right? Because I think the grading rubric says that the item count is 15 points. Let me double check that, unless somebody knows off the top of their head. Yeah, so if you don't have the item count working, you lose 15 points. That's not a big deal, right? So my suggestion would be get this working, add in the caching, submit that, right? Get that into Git. Now, you can get abducted by aliens and you still get 85 points out of 100 on PA5. But then, if you want to get the item count, go back and make your changes to have max val return as struct and do the adjustment of the item count and so on. And then you're going to have to change your caching But that's really just changing what type of array you're using. You're using an array of struct answers instead of an array of ints, and initialize all of the max vals in your array to be 0 so that you can tell whether or not you've saved an entry in there. Not that we want to be sloppy, but will you be testing for Valgrind memory leaks? No. And I'm not expecting that people are doing any kind of memory allocation here, so so you shouldn't have any memory leaks. Hopefully you close your file when you're done reading the database, but no, I'm not going to Valgrind it. So, so you're fine either way. Be sloppy. All right, other questions? All right, cool. So let's talk about egg drops. And when I was an undergrad, every year our engineering department, wait, I thought this was using dynamic memory. I don't think there's any dynamic memory you have to use in PA5, because I made the simplifying assumptions for you that you have a maximum of 128 items, so you can just make static arrays of length 128. And the largest capacity that you have to handle is 1024. So your array of cached values only has to hold 1,025 elements, right? Basically bracket 0 up to bracket 1024. And everything in here is just, you know, just locally declared. So it's all static memory. So I don't think you need to do malloc anywhere. You could, but it's not necessary. You can get away with just declaring at compile time. You could do it for practice, definitely. The name of each item is limited to, I think, 32 characters. And yeah, so it's 32 characters, and since we know we have at most 128 items, you can just make each item 32 characters. All right, so egg dropping seems to be a thing at a lot of departments. So my undergrad, George Washington University, we had an egg drop competition every year where you try to build some contraption and throw an egg off the top of the engineering building and see if it survives. It was a 4-story building. So let's explore a problem related to dropping eggs. And here's our setup. So some kind of building, and it's got a collection of floors. And you have a basket of eggs. And our basic question is, what's the highest floor from which you can drop an egg and have it survive? So we're going to make a function, egg, which takes a number of eggs and a number of floors, and it returns, well, we don't know what the highest floor is going to be, because it depends on the eggs and depends on the pavement and all that kind of stuff. We can't write a program without a lot more information to answer this. But here's what we're going to try to answer. We're going to say how many experiments are sufficient to answer this question. Okay, so return guaranteed, return the best guaranteed sufficient number of experiments. to determine what the highest floor is. From which a dropped egg will survive. Okay, that's a horrible run-on sentence, but here's the idea. We don't know anything about these eggs, we don't know what their composition is and so on, but we can conduct a series of experiments to answer this question. And depending on how you run these experiments, you might be able to answer the question, you know, with a few experiments. It might take you a great many experiments. And there are some sets of experiments which are guaranteed to give us an answer, and there's some which might not give us an answer. We might run out of eggs before we answer our question. So what we want to do is we want to say, over the space of all possible sets of experiments that we can conduct, what's a guaranteed sufficient number of tests? All right? I want to be able to say, hey, with, you know, this number of eggs and floors, I guarantee you 7 experiments I can answer your question. And I want to know that 7 is the best I can do. If somebody else can guarantee that they can do this in 5 experiments, then I want my function to return the value 5. So this is returning the best guaranteed sufficient number of experiments to answer this question. And we make some simplifying assumptions. So all of our eggs are identical. If you drop an egg and it survives, it was not damaged. It will perform exactly the same after that experiment as it did before. So if I drop an egg from the 2nd floor and it survives, I can drop it 1,000,000 times from the 2nd floor and it will survive. It makes no, you know, increasing damage to the egg. And if an egg survives from a particular floor, it's guaranteed to survive from any lower floor. Alright, so totally idealized situation. So 1 egg is sufficient. If you have 1 egg, how do you answer this question? How would you conduct experiments to tell whether or not what the highest floor is that an egg will survive if you only have 1 egg? Start from the bottom and go up. And that's the only way you can do that. That's the only set of experiments that's guaranteed to give you an answer. If you only have 1 egg, you have to drop it from the 1st floor first. And if it breaks, you got your answer. Floor 0 is the highest. If it survives, now you can go to floor 2 and drop it. And if it survives, you can go to floor 3. And if it breaks, floor 2 is the highest floor. But that's your only set of experiments that will get you an answer. Because if I take my egg and I start from floor 2 and it breaks, I don't know if it would have survived from floor 1, and I don't have any eggs left. So 1 egg is sufficient, but it might take you F number of experiments. If it's going to survive from the top floor, you won't know that till you get up to the top. So let's write some code for this egg function. And we already have a base case. If the number of eggs is 1, the best we can do is say, hey, it's going to take F experiments. Experiment 1, 2, 3, 4, 5, 6, 7, 8. 8 floors. It might take 8 experiments. You might get lucky and you find the answer after 1, but we can't guarantee that. If this is like a super duper kryptonite egg, right, we might have to test every single floor up to the top one. So the best we can guarantee is F experiments. All right, on the other hand, if there's only 1 floor in the building, we only need 1 experiment. Drop it from the 1st floor. If it survives, then the answer is 1. If it breaks, the answer is 0. The limit as the egg approaches destruction of the height it is dropped from. Excellent. Oh, iPhone drop test. No. And I'll throw in an extra base case here just in case for some reason we test this with floors that are, you know, a building with no floors or with fewer than 0 floors. We don't have to do any experiments.